Chapter 5, A through C. We're going to start by evaluating function f evaluated at x plus 3 and then subtract 4. So what we're doing is we're plugging in the x plus 3 for the x value in f of x. So what we end up with is x plus 3 quantity squared minus 4. Now we can simplify this. So x plus 3 quantity squared is going to give us x squared plus 6x, remember we're foiling here, plus 9, and then minus the 4 is still tagged on there. And there's some last like terms to combine. So our finished function is x squared plus 6x plus 5. And what this is it's really a horizontal translation of 3 units to the left and a vertical translation of 4 units down. And we can give that translation in this vector notation, -3, -4. This x squared plus 6x minus 5, if we were to look at it graphically, we would see the vertex is shifted left 3 and down 4, but it had the same basic shape. So some properties here. If we have a function, a parent function, we're adding some constant onto the end. If that constant b is greater than 0, the graph is shifting up. If that b is less than 0, the graph is shifting down. If we have a constant being subtracted from the x, so a constant inside the parent function, when that constant is bigger than 0, in other words, when it's x minus something, remember we're looking at what we're subtracting from x, then the graph is shifting to the right. When that constant is less than 0, the graph is shifting to the left. So in that case, the function would say x plus a number. We can combine these translations into one notation using a vector notation where the top number in this matrix, if you will, is the horizontal shift and the bottom number is the vertical shift. Remember that vertical shift is always outside the parent function and the horizontal is inside. With stretching and compressing, if we're multiplying the parent function by some constant p, if p is bigger than 1, what we end up with is a vertical stretch. We're getting taller. We're grabbing the two ends of that parabola, or whatever graph it is, and pulling up and down. If p is between 0 and 1, what we're looking at is a vertical compression. And we can think of that if we press down on the top of a parabola, it sort of moves farther from the x-axis. If we have a constant inside the parent function and we're multiplying it, it behaves backwards from what it does with the vertical stretch or compression. If k is greater than 1, it's a horizontal compression. If k is between 0 and 1, it's a horizontal stretch. If we have a negative in front of a parent function, we reflect across the x-axis. If we have a negative inside the parent function, we're reflecting across the y-axis. So here we have a parent function, 1 over x, and we're going to transform it with a vertical stretch, a horizontal compression, and a translation. So we start with the basic form, something over x. And now we have to look at the different pieces. We know that there is a vertical stretch of 2, so we're multiplying the parent function by a factor of 2 on the outside. So 2 times 1 over x will have 2 over x. We can also look at the fact that we have a horizontal compression. We know that inside the parent function we'll have to be multiplying by 3, so that means that we're going to have a 3 down in the denominator. And then we also have the translation. The vertical translation is the easiest part to deal with. We're just going to tack on a minus 2 to the end. But we also need the minus 3 on the denominator because that is the horizontal shift. It's positive 3. Now the question becomes, did we get this right? We could look at a graph and look to see if we did get it right, but we want to shift the graph and compress that shifted graph by a factor of 3. That factor of 3, the horizontal shift needs to get multiplied by it also. We can't say that the number being subtracted from x is the horizontal shift unless it's just plain x minus something. So if there's a coefficient in front of x, that needs to get factored off. And once you have that denominator or the parent function in this factored form, so it's just x minus something, then we can talk about what the horizontal shift is. And we should give it a name. We'll call it f of x. Now we're going to go the other way. Here we have a rational function. We want to know how it's been transformed from the parent function, and we should graph it and label the asymptotes, the important features, and we have to find the asymptotes. And that can be easily done by rewriting this, essentially undoing adding of fractions. So what we want to have happen here is we want to end up with something over x plus something. And then there's probably going to be a horizontal shift involved with this also. The way this is going to happen is we need to split this numerator into two parts, but we need to do it in a way that the x plus 1 will cancel from the denominator in one part to give us our vertical shift. So what I'm going to do is I'm going to make it x plus 1 on the numerator. But it's really 2 times the x plus 1. And then we still have this minus 6 tagging along at the end. And we can't just add 1 and call it good because now we've changed the value of the numerator. What I really did by putting that plus 1 is I added 2 on top. So to balance things out, I also have to subtract 2 from the top. And that's going to be able to combine with the minus 6. So we take the first part of this. The x plus 1s are going to cancel if we were to split this into two fractions. We're taking this variable part, writing its own fraction, and then minus 8 over x plus 1. And now we can simplify and we'll see very clearly what it was that we did. So the something over x part we have and the constant. Plus 2 is the constant, and then we have negative 8 over x plus 1. Now this is written in a way that we can see horizontal and vertical translations as well as any stretching and compressing that happens. So there is a horizontal translation and a vertical translation. We can express that as this vector notation, horizontal on top, vertical on the bottom. And then that negative on top, the negative 8, means that we're reflecting across the x-axis. So this graph is flipped from what the parent function would look like. And this graph also will have a vertical expansion by a factor of 8. Now, the asymptotes are normally for 1 over x at x equals 0 and y equals 0. Because there's a translation of 1 to the left, our new vertical asymptote would be x equals -1. Our new horizontal asymptote would be at y equals 2. And the branches of this hyperbola would be in essentially what was, before the shift, the second and the fourth quadrant. And it will be very steep as it approaches the y-axis.